Today we're going to talk about roots or zeros or x-intercepts. These all mean the same thing. And since we know that an x-intercept is where the graph crosses the x-axis, whenever I talk about roots or zeros, that's the same thing I'm talking about, is where the graph crosses the x-axis. And the way that we're going to find them, to start off with, is that we will set the y value equal to 0 and then solve either by factoring, completing the square, or quadratic formula if we have a degree 2. Later on we'll get into examining higher degree polynomial functions. So I want to look at two different equations. Oops, that's going to be minus 6x plus 9. Just ignore that little scribble. So for this first one, we are going to set the y value equal to 0, and that gives us the equation 0 equals x squared plus 2x minus 15. We can solve this by factoring. So we'll have x and then plus 5 minus 3. And then remember that we set each factor that has a variable in it equal to 0 and solve, giving us x equals negative 5 and x equals positive 3. Let's look at the other equation, and then we're going to compare those graphs. So 0 equals x squared minus 6x plus 9, and that factors to x minus 3 times x minus 3, so we get x minus 3 equals 0, x equals 3, and x minus 3 equals 0, so x equals 3. So I want to look at these two graphs on our graphing calculator, and I want us to observe what happens when a factor or root appears once in our factoring, and what happens when a factor or root occurs twice. So let's make a couple of observations. So I'm going to get my graphing calculator, and we're going to graph y equals x squared plus 2x minus 15, which would be the same as graphing x plus 5 times x minus 3. And let's see what happens. So we have a parabola shape, and our graph crosses the x-axis at negative 5, which was this root, and at positive 3, which was this root. So when a factor or root appears once, the graph is going to cross the x-axis at that value. So that gives us an x-intercept. Let's see what happens on our other one. So y equals x squared minus 6x plus 9. And we found that it had a root at 3 and 3. So if we look at positive 3, what's happening there is that the graph doesn't really cross through the axis. The graph either bounces or touches the x-axis at that value. And that's actually an important concept that we need to talk about, called multiplicity. Multiplicity is actually the number of times a factor. Now a factor is this x plus 5 and x minus 3 and x minus 3 and x minus 3. So the number of times a factor or root or x-intercept or 0 occurs in a function. So as we saw here, if our factor occurs an odd number of times, what's going to happen is that the graph crosses the x-axis, and what we'll see later on is that if it's bigger than 1, so, well, not x, if the multiplicity is bigger than 1, so if we have a multiplicity of 3, which is odd, then the graph doesn't necessarily cross straight through. It sort of wiggles through the x-axis at that point. If you think about the graph y equals x cubed, remember that was the squiggle graph, so it kind of wiggled through at that point. If you have an even multiplicity, the graph just touches or bounces the x-axis at that value, but it does not cross. And what you'll see is if it's bigger than 2, then it still is going to bounce or touch, but it sort of flattens out a little bit more at that spot. So that's just a little different in the appearance. So let's look at an example of a function and talk about the multiplicity of the roots. So here's an example. This one I'm going to have all factored out for you. So I'll have 4x times x plus 1 squared times x minus 1 cubed. And first of all, I want to identify the factors that are in this polynomial, and then we'll talk about the root that goes along with the factor and what the multiplicity is at that spot, and then how the graph appears at that multiplicity or at that root. Okay. So let's kind of work our way from right to left. The factor that's all the way at the end here is x minus 1. In order to get the root from that factor, we'll set x minus 1 equal to 0, and we will get the root x equals 1. So that tells us that our x-intercept would be at 1, 0. The multiplicity is found by looking at the exponent. So how many times does x minus 1 appear in our problem? The answer to that is 3. So the multiplicity for this root is 3. And since 3 is an odd number, the graph is going to cross the x-axis at that point. Our next factor, as we move from right to left, our next factor is x plus 1. So the root that would go along with that, when we set x plus 1 equal to 0, would be x equals negative 1, and the ordered pair for that is negative 1, 0. The multiplicity is 2, because that's the exponent on that root, which is an even number, so the graph is going to touch the x-axis at that point. Then we have this 4x. Now 4x, since it has a variable in it, is a factor. So 4x is a factor. And to find the root, we'd set 4x equal to 0. Divide both sides by 4. That gives us x equals 0 for our root. So our x-intercept will be 0, 0. The multiplicity for this root is the exponent that's on the x. And that is an understood 1. So our multiplicity is 1, which means our graph is going to cross the x-axis. So let's see if we can get a quick picture of this graph on our calculator. Y equals 4x times x plus 1 squared times x minus 1 cubed. So we should have, if we move left to right on our graph, at x equals -1, we should have a bounce, which we do. At x equals 0, it should cross through. And at x equals 1, it's going to cross through, but since it's a degree 3, it sort of wiggles. Let's zoom in. Oops. Zoom into right there. So at -1, it bounces. At 0, it crosses. And at 1, you can see it kind of wiggles as it goes through that root. Let's look at one more example. This one, we are going to have to factor ourselves. So f of x equals 5x to the 4th plus 15x cubed minus 50x squared. When we factor this polynomial, the first thing we want to do is look for a greatest common factor. Each term is divisible by 5, and all of the terms have at least 2 x's. So f of x will be 5x squared times x squared plus 3x minus 10. Then we'll break down this parenthesis. So f of x equals 5x squared times, let's see, it's going to be x and x, and then to get 10, I can take 5 times 2, and I need a positive 3, so it'll factor 5x squared times x plus 5 times x minus 2. Then each of my factors, I'll have 5x squared as a factor, x plus 5 as a factor, and x minus 2. Then the roots that would go along with that. If I set these equal to 0, this one gives me x equals 0. This one is x equals -5, and this one is x equals positive 2. The multiplicity on our 5x squared, the x is squared, so the multiplicity here is 2. This one is 1, and this one is 1. And then at these spots, the graph would touch or bounce, cross, and cross. In future lessons, we're going to use these x-intercepts to actually create a graph, but for now, all I'm going to ask you to do is identify the roots, multiplicities, and describe what would happen on the graph at that point.